We are talking about tessellation in OpenGL. So, OpenGL is a kind of GL library. All the calls are happening through GLC API. So, OpenGL is not a kind of technology which can draw polygons like triangle or quad. If we talk about the fixed function pipeline, so it can draw triangle, it can draw quad, it can draw lines, points, but polygon has to be convex. Polygon cannot be concave. So, GL cannot draw kind of any polygon that is concave. So, what is the solution? Means how we can draw a concave polygon. So, the rescue is like someone has to write the algorithm, and which would kind of like if I draw any primitive like triangle, triangle fan, triangle strip, then I typically I write GL begin and GL end, and GL begin I provide the primitive name, and in between I can specify color, I can specify normal, I can specify I can specify texel, I can specify the vertex. So that is the idea. But since it is a concave polygon, so if I want convex polygon from it, then I have to kind of distribute the concave polygon into many polygons. I may just need to divide into 2 convex polygons, 3 convex polygons, or I need to reintroduce I need to introduce new vertices, and then so many convex polygons. So many convex polygons can come together and they can create a concave polygon. I mean, if I have a concave polygon, it can be kind of distributed among so many convex polygons. Who will do this much? So there is another library called GLU, so GL utility library. So they provide kind of algorithm for converting concave polygon into convex polygon. So that is the idea behind the tessellation GLU library. So if we give the concave polygon to the tessellation library, then it should give back kind of set of convex polygons, and that we can do. So that is the idea. Okay, so it looks pretty simple, like input output. Input is concave polygon to the GLU tessellation library, and output is set of convex polygons. Each convex polygon has a unique primitive. One is triangle strip, one is triangle fan, one is triangles, one is line, whatsoever. So I can get a set of convex polygon with a primitive, and then I can draw. So this is what GLU tessellation library does. So we'll see it is in Python. So Python has kind of a little bit, language is different than C. So binding is a little bit different. So what is the concept kind of how we can go ahead? So we know this much, that input is concave polygon in the GLU tessellation library, and output is a set of convex polygons. Each convex polygon is kind of has one primitive. But how to kind of generate this? It's not that straightforward that I just send it input and a bunch we get in out. So tessellation library has its own way to be used, how it can be used. So that we'll see. Like typical drawing, we provide GL begin, in between we provide color and texel, normal, then vertex, set of that, and then we do GL end. So GLU tessellation library, they does the same. So whatever we receive, we write for ourselves to draw a particular primitive or set of primitive. Set of primitive means set of GL begin end, GL begin end. So that is kind of done. So we get a full code written by the GLU tessellation. We don't receive the kind of set of convex polygon. We receive full code, GL begin to kind of a GL end. How it is done? They provide kind of 6 kind of callbacks. The way we write, like one is for begin. If it starts the drawing it, then it will call the begin. Inside it we can write in the callback GL begin. If it ends, then it will call a callback. That there we can kind of write GL end. If it meets a vertex, then it will call kind of callback as vertex. If it meets an error, then it will call a callback called error, similar to that. If it has to draw, if it kind of find an edge, then it will. So we can call something edge flag in the callback. Or the biggest thing is the combine function. Like if tessellation library kind of it finds a new vertex. Whatever vertices we specify as our concave polygon, like concave polygon example can be like a typical concave polygon or a polygon which has holes or star kind of polygon where kind of edges are intersecting each other, self-intersecting each other. So this kind of scenario. So how tessellation work is it work in a kind of a contour fashion. Like if I have a polygon and there is a hole inside it, so I have 2 contours. One is the outer one and one is the inner one. Okay, so outer vertices and inner vertices. So this way we have to provide contours. So like if I want a star, then there is only one contour, that is the external one that I need to provide. So if I provide the star, then now it is up to the tessellation that how it will kind of draw the vertices. Because OpenGL is a game of vertices. You decide the vertices, you decide the primitive, and then it thinks about the rasterization. Programmer should not think about the rasterization. Rasterization is kind of done by the OpenGL itself. So to the input to the tessellation, again, we have to provide the concave polygon vertices, and it takes in contours like what is your kind of how many region you have. Like if I have a star, I have one region. If I have a polygon with one hole, then I have 2 set of boundaries. One is outer boundary, one is inner boundary. If I have 2 holes, then 3 set of boundaries. So these set of boundaries are called contours. So we start with the kind of we start the tessellation, and then we keep specifying the contours. And if it finds a vertex, whatever we have specified inside the contour, it calls the vertex callback. Or if it feels that a new vertex has to be introduced, so that is the most crucial. If it feels that new vertex needs to be introduced, then it calls a callback called combine. And in that combine, the new vertex kind of coordinates are there, and the vertex data is there, like normal or color or texture, whatever we are pushing in the contour. So we give concave polygon as input, and we receive set of convex polygon as output. The methodology is giving input is kind of in contours, and output is in callbacks. Input is concave, output is convex. Okay, but the real scenario is input is all the boundary vertices. Like a star is only one boundary vertices. Polygon with a hole, there are 2 boundary vertices. That we push in as contours, and the output is callbacks. So in callbacks, every time one convex polygon is coming, then begin will get called, and then vertices or combine vertices, and then end will get called. Next convex, begin will get called, vertices, combine vertices, and end will get called. If in the contour we are passing texel, normal, these color, these kind of stuff, they will come as vertex data in the callback. Pretty simple. So the tessellation library works like input is convex, output is set of convex polygons. Set of convex polygons are nothing but they are called through callbacks. So if a polygon starts, a particular convex polygon starts, begin is called. Now user would kind of just call GL begin on the primitive, whatever primitive it is returning from the callback. And then set of vertices and flag, edge flags, and combine for new introduced vertices, and then end. Then begin, edge flag, vertices, combine vertices, end. So begin and keep on happening like the way if we receive the set of convex polygons with the primitives, then we will specify so many begin and end. Same way callbacks will come. So here methodology is common. So we'll see the programming way and the slides like how it comes to kind of the actual picture in Python. Okay, so we are on Linux Mint. So we'll proceed on OpenGL Tessellation. Okay, so OpenGL Tessellation is kind of, it does tessellation. I mean, it modifies it. Okay, so what it does, OpenGL can draw only convex polygon. So this is kind of a limitation with the OpenGL. And all OpenGL in Python, all OpenGL functions, subroutines, definitions, they come in package OpenGL.gl. OpenGL is top package and GL is a sub package. Okay, but drawing a OpenGL extension library, GL is capable of converting concave polygon to set of convex. So at the end, when we draw a convex polygon through OpenGL, so someone has to come forward and it would modify the concave polygon to convex polygon. So GLU is the extension library and it provides, so that comes under OpenGL.glu and it does the job. So it converts the concave polygon to convex polygons. One concave polygon to multiple convex polygons. So this is a concave polygon. Okay, so these are kind of typical thing that is kind of that is cannot be handled by OpenGL. This is concave polygon. These are polygon. This is polygon with hole. So this is interior area that need to be drawn. This is the region that need to be drawn, and inside this is a hole. And this is self-intersecting polygon, where this mid area, this does not require to be drawn, whereas these triangles need to be drawn. Okay, so this is how they are related to each other. None of them is convex polygon. This is not a convex polygon. This is not a convex polygon. This is not a convex polygon. What is convex polygon? Okay, if any two vertex, if we draw an edge and it fall outside the polygon, then it is not a convex polygon. Like This is the shape that we saw. This is the shape that we need to draw. And these two, this vertex and this vertex, if we draw edge, then it comes out of the polygon. If these two vertex, this vertex and this vertex, if I draw edge, that is the green one, okay, it is not inside the polygon. So inside the polygon is this region. This region. This is whole. This is, we don't want. Okay, but still, this is the vertex. So there are 4 vertices. Okay, 2 vertex, 2 vertex, 4 vertex. There are 8 vertex, and then these 2 vertex and these 2 vertex. There are 8 vertex. Any vertex, if 2 vertex I take and draw an edge, a line, it must be inside the polygon, but it is not inside the polygon. Here also that is the case. So this is kind of not a convex polygon. Whatever it is not a convex polygon. Means OpenGL cannot draw this. Okay, so we can have some algorithm and it divides this into 2 triangles, 2 convex triangles, left and right. So this triangle has 3 vertices. Any vertices between 2 vertices, if I draw an edge, it will come inside the polygon. It cannot go beyond the polygon. You see another triangle. Like this, there are so many triangles. So green color what we see, it is a kind of a triangle strip. It is divided into so many triangle strips. And red what we see, it is triangle. So whatsoever. So it is divided among so many complex triangles. And this guy is done. No need. So if I draw these triangles and one red triangle, then it will become like this. A region, a square region, square filled region, where the central portion is empty. It's a hole or a star, self-intersecting polygon. So here we can have triangles. 1, 2, 3, 4 and 5. If we have 5 triangles, we draw as per the coordinate, then we are done, 5 convex triangles. So idea is someone should come ahead, and if I push in, these are inputs, it should come out with these kind of triangles, convex triangles, set of convex triangles. Okay, something like this. GLU tessellator is an engine, and the input is a concave shape and output is set of convex. Input is concave shape and output is set of convex shapes. So that is the idea of GLU tessellator. Okay, like what we showed in the last slide. So these two are triangle fan, whereas the green color what we see is a triangle strip and red color is GL triangles. And here all are GL triangles. So what is GL triangle, GL triangle strip? Okay, how things are achieved and what we want. So at the end, so we are talking about the fixed function pipeline. So we are not talking about shaders. Okay. So like if we draw any primitive, then we call GL begin and we call GL triangle. Okay. So that is the primitive. Okay. So we call GL triangles. Okay. So, like GL triangles is a primitive. So, when we write OpenGL code, we typically call GL begin triangles and then we specify color of the vertices. So, here set of vertices, so 3 vertices we will specify in the GL triangles, and so 3 vertices would be kind of color, and then what we are seeing that is normal, and text coordinate text, and then we have actual vertex. So that is the idea. Okay, so this is the kind of any OpenGL code we write in this fashion. GL begin, then primitive, and here we specify all the attributes of a vertex like color, normal, text coordinate, and vertex. Then again color, normal, text coordinate, and vertex. So 3 vertices we specify and we end by GL end. So this code, whatever we are writing, that will be provided by this GLU tessellation. Means how it works. It doesn't return the set of the way we discussed. It doesn't return the set of kind of convex triangles. So user calls the GLU tessellator algorithm, and this reads any concave shape, and then it calls for us, like it calls some callbacks. In callbacks, we have to insert our code. So callbacks kind of begin callback. So in begin callback, we call GL begin. End callback, we call GL end. Vertices callback. In vertices callback, we specify all this. So we receive the data as function argument. Okay, there is another callback called combine. Like this, if you see the shape, then yellow color, this is the original vertex. There are 5 yellow colors. This is the original vertex. And 5 more vertices, that is the GLU tessellator algorithm is generated. So, for vertices, what we are providing, the callback is vertices. For vertices, what OpenGL is generating, for that callback is combine. So, in combine, we have a chance to kind of generate vertex, color, text coordinates. So there is a data that is provided in the callback, in the combine, and we generate these data and we return. Then finally it calls the vertex with this data. So the 3 callback function that is mainly of our interest, one is begin, one is end, and one is vertex. Vertex, we receive the vertex coordinate and all these attributes. So whatever we specify these attributes, that is returned in the vertex callback, or if a vertex is new, that is generated by tessellator, then combine callback comes, and there we have to resolve all these attributes and we have to return. If we return, then it calls vertex callback with those parameters. So I think it's quite clear. Okay, so we'll move to kind of contours. So how it works? Now first idea is that concave polygon should come inside the tessellator and set of convex polygon should be generated. Then we saw that if we pass a concave polygon, tessellator would call callbacks like begin callback, end callback, vertex callback, combine callback, error callback, edge flag callback. So in callbacks, like in begin callback, kind of we call GL begin, in the end we call GL end. So in the begin callback, as a parameter we receive the primitive name, and so if there are many primitive, means there are many type of convex shapes, then GL begin callback will be multiple times. GL begin, GL end, GL begin, GL end, that we'll see. And we'll receive the primitive as kind of argument, function argument, and then we'll receive then there is a callback called vertex. In the vertex we receive all parameters what we have specified. So like if we call GLU tessellator algorithm, we specify vertices. We specify 5 vertices like this. If I specify 5 vertices like this in a in one direction, if I specify this vertices first, then this vertices next, then this vertices next, then this vertices next, then this vertices next. So we are following a direction. So if I am following a direction, then GLU tessellator understands the direction and then it thinks about the a possible new vertices. Like these 5 are new vertices. So vertices, vertex coordinate and its attributes like color, normal, text coordinate. So all this it calls in another callback called combine callback. In combine callback, we receive as a vertex data and we resolve it, and finally we return like a vertex and other attribute. Whatever we return, it comes back in a vertex callback. So there are 4 main callbacks that we are interested in: begin, end, vertex. Vertex callback what we specify as vertices of a input concave triangle, and combine callback where new vertices are coming. Then OpenGL Tessellation calls it with new vertices and its attribute in some format, and that we resolve and we make it in our format and we return, and that again with that format vertex callback will get called. So that is the algorithm. So if I specify a shape, like this is a shape, and where this is one region, like region 1 that we are showing. This is region 1. Okay. So this is region 1 and this is region 2. So region 2 is inside. Full is region 2. All pixels here is region 2 and this is region 1. This is region 1. We are interested in region 1. We call region 1 as interior and we call region 2 as exterior. Exterior means I don't want. Okay, I want to be drawn this one. Okay, so this is interior and this is exterior. This is interior and this is interior means we want it. This is exterior, we don't want it. So that is what is interior and exterior. Okay. So arrow is how we specify, how we call the vertices. If I call these vertices first, this next, this next, this next. So this is called one contour. That means whatever we specify as a a closed area, a region, that becomes a contour. This contour is anti-clockwise. This contour is clockwise. Okay. And there are 2 kinds of contours. One is clockwise and one is anti-clockwise. Okay. So this contour is clockwise. So if it is clockwise, then it is negative. Okay. So if it is clockwise, so we specify it as negative. So it should be negative. So this is negative. So this is again negative. So 2 clockwise we are mentioning. 2 clockwise means 2 negatives. So -1 again -2. Okay, this is clockwise, so this is negative. Okay, so this is negative again. Okay, so this is clockwise, this is anti-clockwise. I believe one line is. This is clockwise and this is anti-clockwise, and this is again anti-clockwise. So it starts with -1, then clockwise means +1, 0, and then it is 1. Okay, so we'll describe it. Okay, it's pretty simple. Like if I want a polygon to be drawn, then I have to look for the kind of interior and exterior. Then if this is interior in the polygon, this is what I want, and this area is exterior, this I don't want. So there are two contours. Top contour, if it is clockwise, then its region is known as -1, and if it is again clockwise, then it will add and it will become -2. Or if this is a kind of 3 contours are there, and if it is clockwise, it is -1, this full region is -1. If it is anti-clockwise, then we'll add +1, it becomes 0. This full region is 0. Okay, next one, again it is anti-clockwise, again we'll add 1. So if it clockwise, we subtract 1. If it is anti-clockwise, we add 1. Okay, so here, everywhere it is, so there is top contour and it is anti-clockwise, so it is 1. Okay, so considering that inside is 2, this is also anti-clock. So if I know that if I specify the vertex and these are the contours in which direction we know, then what we want? So there is something called GLU test property. In GLU test property, property and value, that is the winding rule, and value you have to specify. If I say odd, then this is odd, this will be drawn, and since this is even, it won't be drawn. Here, this guy will be drawn, this is odd, this will become exterior, it's a hole, and this will be drawn. Here, only 1, 1, 1 will get drawn and 2 will become exterior, means a hole. If it is non-zero, everything is drawn, so full is like one filled rectangle, filled shape, and here if it is non-zero, means this one and this one will get drawn like what we saw last time, and if it is non-zero, so this hole will not come, it will be filled. So like that, if it is a positive or it is a negative or it is 2 to the power n in the sense all 2's will come into the picture. So this will get drawn, this will not get drawn, this will get drawn, and this 2 will get drawn. So all 2 to the power n, 0, 1, 2, 3, 4 will get drawn. Okay, so we understood the concept. It's quite clear. OpenGL tessellation, it gives convex polygon. So if input is concave polygon, then output is set of convex polygon. How it happens is, it reads the input and we have to register callback. In the callback, we can call the actual GL functions, every callback we have to understand, and then we have to call the actual GL function. Begin callback we call GL begin, end we call GL end. In a vertex we call all these. In the combine we generate the vertices so that those will get called in the vertices. New vertices, if new vertices come into the picture, combine callback will get called. Okay, if we have a kind of shape like this and we want a particular region to be drawn and particular region to be kind of not drawn, exterior, whole, in that sense we see how our vertices are laid, how our vertices are called. If it is clockwise, it is -1, region is -1, and we keep going inside and we keep adding it. So -1 and -2 both are clockwise. Here it is -1, but it is anti-clockwise, so we have to add 1. So 0, again anti-clockwise 1. Here again outside all 1 and then inside 1, plus 1, so 2. So this is all about kind of tessellation, and we'll see in the example code. So in lab session, we will actually draw what we showed, like this is a kind of this is a concave shape, and this is a hole, and this is a star. So that will actually draw. Okay, so that is the scenario. If it is red and kind of difficult to see, then we can kind of convert it to white. Okay, so this is the concave, this is with the hole, and this is what we see in the kind of star, self-intersecting polygon. So that we'll see in our example. Okay, so we'll start writing the code. Okay, so we'll create a directory called tessellator. Okay, so it's empty directory. Now we will kind of write a code called test.py. Okay, so from OpenGL.gl import star, from OpenGL.glu import star, from OpenGL.glut import star. Okay, now concave equal to okay, so all three polygon will describe what we stated. So 1.40 0 0 0 0 1 1.40 0 1 0. Okay, so this is concave polygon. -1 1.40 0 1 1.40 and 0 1 0. Okay, so this is concave one. So that's it. Slowly we'll go for others. Now we'll have function like def begin. I think it will be complex. So We'll write kind of a typical OpenGL code first, then we'll insert what we want. So def init, so this will get called, and here we'll say GL clear color, GL shade model, GL smooth, GL enable, GL depth test, okay, and then we'll kind of write the display, def display, okay, and GL clear, GL color buffer bit, GL depth buffer bit, GL push matrix, GL translate 0, 0.5, okay. So this is the typical call, GL pop matrix and GL flush. Okay, so this is the typical OpenGL code, Python OpenGL. Okay, so def reshape, GL viewport 00 WH, GL matrix mode, GL projection, and GL load identity, GL ortho, this is what we are using, minus 1.5, 1.5, minus 1.5 into 110, if width is less than equal to h, else GL ortho minus 1.5 into width by height, 1.5 into width by height, minus 1.5, 1.5, 1 and 10. So this is GL ortho. If width is less than height, then we kind of do like minus 5 to 1.5 and height by width. Or if width is bigger than width by height, this is what we said. GL matrix mode, GL model view, and GL load identity. Okay, so we are done. Now we'll write a kind of the initialization. If name equal to main, so this is module name. So module name is main, so we are not into a library. We'll say glut init, and glut init display mode, glut single, glut RGB, glut depth. Okay, I believe RGB is not required, so just will not use double, will use single only. Glut depth, glut init window size, 500 by 500 glut init window position. So at the beginning here it will be create window, and it is kind of say later. Okay, so we'll call out our init function glut display. So display func is display, and glut reshape func is reshape. Glut main loop. Okay, so we are done. We'll see the code again, and then skeleton code will run. So concave we have set, that we'll see. Otherwise it is pretty clear, and I believe it should we should able to. So Python test.py. Oh, so we get the window. I mean, it's really a window. So we get a window. Okay, so we'll proceed. Now we'll start filling. So where we can we want the code. So when we go to init, okay, so now in the init we enable the depth test. Here we'll create a tessellation. We'll create a display list. So whatever instructions, the instructions, what we see, these instructions, GL begin, GL color, whatever this library is generating, we can push in a array, and then we can in the display we can draw it. So rather than pushing in an array, we can push in a display list. In our array, rather than it can be compiled, so it will be first. So I'll say I have a list ID equal to 0, and here I'll say global list ID, and list ID equal to tessellate. Now tessellate is a function which will do the tessellation, and it will push everything in a display list, and this is the idea of the display list. So we'll write tessellate function. Okay. Okay, so we'll write after this tessellate. So we'll have a a start list equal to GL gen list. So we are generating a list, display list 1, and T of is GLU new test. Okay, so how it happens is we have to create a tessellator object. Like if we want a display list, we generate a display list. So tessellator object is a stuff that it encapsulates all the tessellation operations. So whatever tessellation operations we are doing, tessellation operations can be many on a particular machine, OpenGL. So in order to differentiate between many tessellation operations, we do a namespacing. We do one confinement. We place one scope. So whatever work we are doing, it should come in a scope of this object, so that it should not interfere with kind of other tessellation operations. So whatever tessellation operations we are doing, it will be in reference to this tessellator object. So we create a tessellator object. Now we specify the tessellator callback to GL test callback, and so first is the object reference. What we want, GLU test vertex. For this, the callback is vertex callback GLU callback T of GLU test begin. So vertex begin callback GLU test callback T of GLU test and GLU test callback T of GLU test error callback GLU test combine. Then we have combine callback. Okay, so this is the idea. Now GL new list start list. So now we are kind of placing in a now we are kind of compile the display list to GL compile. So whatever list we started, GL start list, now we compile it, and now we'll kind of write GLU test begin polygon. So when we start doing the tessellation, we start with kind of writing GLU test begin and GLU test end. So begin and end, in between we'll place the contours. So GL test begin, and in the context of T object, and there is no user data we are kind of writing now. So this is Python, so we cannot go beyond the kind of indentation style. So we have to write everything in same indentation. GLU test begin polygon, GLU test property. We discussed the GLU test property. So for T of GLU test, or I think we can avoid this. So by default it is odd as we described. So GLU test property by default it is odd. So odd numbers it would take. Okay, or we can just comment this GLU test property T of GLU test winding rule, GLU test winding odd. So winding rule is GLU test winding odd. Anyway this is default. Now GLU, so we start contour to GLU test begin contour. So this is one contour, first contour, and it is in context of T of, that is a tessellation object, and so I'll say for I in range length of the concave is the polygon. So this is, at the beginning we wrote concave polygon, so that polygon. Now I'll say GLU test vertex T of concave I. So GLU test vertex, first parameter is the object, second parameter is the vertex. So I'll say rather I and up to 3 and concave, then vertex data, not user data, vertex data. So concave I, complete thing we can specify. I think we are done. That's it. Now I can say GLU test end contour or the T out, and followed by will end the polygon also. GLU test end polygon T out GL end list, and we'll delete this tessellator object we don't need, and we'll return the start list, that is the kind of a display list what we wrote. Okay, so this is the code. Now we have a tessellate function. Okay, we initialize one display list, we create our tessellator object, and then we specify the callbacks, and then we do GL test begin polygon, we specify the contour is the concave one. Okay, only one contour is there in the concave that we see. There is only one contour, that is the outside one. Okay, so in the concave there is only one contour we see, whereas in the polygon with the hole there are two contours. Self intersecting also there is only one contour, that is the outside one, that we will specify. Okay, so inside contour that will leave on the GLU tessellator. Okay, so only one contour is there in our concave polygon, and that we have specified. List ID is 0. Now in the init we call it and we receive the list ID. Now this list ID will be so in the display actually we need to call the GL begin, GL end and all that. So here we can say GL call list whatever we have gathered, and we'll say list ID. So we do not need to specify as global because we are using it. So it's a free variable in Python. So it's okay. Okay, and that's it. Okay, so we are done. So we'll now finalize the callback functions and then we'll start. So we'll start with the begin callback. Def begin callback, and which primitive. So we'll place one kind of debug function and where begin callback, and we'll kind of call which, and here GL begin, we call GL begin and which. So this will be pushed into display list. Now we have end callback. So this also kind of will just print a debuggable that butterfly is kind of open butterfly is the beginning of the function. That is typical. That's it. So we'll say end GL end. Now for error we have registered, so we'll say def error callback, error code, and we'll just have a printf error has happened, and what is the error code, and GLU error string would give error code. Okay. Def vertex callback. Now for vertex callback, so def vertex callback, and we get vertex. I would say vertex data because it can be very big. So I'll have a kind of one debuggable message, vertex callback, and what is vertex data? Okay, and we'll say GL color. Okay, so I'm not saying 3F 4F. I think it should be okay. Vertex data. So begin first is kind of okay. So first is vertex, then color. So after 3, if length of vertex data is greater than 3, else none. We don't want coloring. In that case, GL vertex is the mandatory parameter, and it is first 3 data. So we are done with the vertex. Pretty simple. In Python, big code looks like very simple. Okay. Now we'll write combine callback. So first it coordinate, next is vertex data, and is weight. So coordinate we receive, and vertex data we receive for the other parameters like color, normal, texel, and like if we receive a new vertex, this is what we are showing with the red color, then it will give the kind of all colors, possible colors for this vertex. I mean attribute of this vertex like color or normal or text, and for each color, like if this vertex receives 4 colors, then all 4 colors will have weightage. It is up to the program writer how it interprets with the vertex data with its weight. So we'll do kind of debugging here also, and we'll say combine callback, and first we'll print kind of type of codes, type of vertex, and type of weight, and then we'll print it. So coordinate typically is a kind of object, so we'll print like star codes. Vertex is no problem, so vertex data and WEIT weight. Okay, how we'll combine now? So I'll say I will initialize the vertex and vertex.extend chords. So first chords is the kind of actual vertex, and now the color and other fundamentals come. So I'll say vertex.append, and in the append section we will append 3 kind of color parameters. So I'll say WEI weight 0 into vertex data 0 into I. Okay, so we'll say for I in range 3 to 6. So first 3 will be vertex, and 4, 5, 6 will be kind of attributes. So append vertex data I. Okay, so this is what it is. So we will not type everything. So kind of I can just go ahead and say weight 1 and vertex data 0 and I. So we can, I think, okay, nice, thank you. So I can say weight 2 and vertex data 0 and I. Okay, so we'll see vertex data. So vertex data is, so that is the, okay, I believe it should be 1 vertex data 1 and we'll see. So right now I think okay, so vertex data 0, vertex data 1, vertex data 2, vertex data 3, we'll see vertex data. Okay, so this is what we are appending now. Return. Okay, so combine is where we receive a new vertex where it is the first 3 is the coordinate and next is the kind of big number that we have to kind of normalize into some combination, and that is the 4th, 5th and 6th parameter, that is the coloring, and that we return the vertex. Whatever we return vertex, so we can kind of log it. So printf combine callback and whatever we are returning we can just show. Okay, so I think we are done. There is nothing that we need to do now. So right now there is no coloring because we are not specifying any coloring. It is a pure vertex we are specifying, and when we are calling contours, so in the contour, in the TS vertex, this is the vertex, and this is full, this is again only vertex because it is only 3 coordinates. So we'll execute it. Okay, GL gen list is not defined, so GL gen list is the wrong call that we have made. So it should be probably GL gen list. Okay, vertex callback is not defined. Vertex callback is not defined. So what we have written? Okay. GLU delete is not defined. Okay, GLU delete test. Okay, the start list is not defined. Okay, start list and then start list, start list. Okay, so nothing is coming. It is, in fact, it is giving error lot of. Okay, so we'll see the code. We'll run again. Okay, GL vertex 3F. So GL vertex 3F. So we are using vector. Either I can place star here so that it will come in a kind of a non-vector form, or we have to specify V here. So anything is correct. So I'll say python3 test.py. Oh, okay, so it is coming. So this is what is being drawn. We can see this is a kind of a concave, and it got divided into two convex polygons. Okay. Now if we see the message, the primitive is 6. What is 6 I don't know, but these are the vertices that got called vertex data, and finally we got that. So there is no combined callback, only vertex, begin, vertex and end. Okay. So what is the so that we have a kind of a hex to primitive, we'll write kind of that we can identify easily. So we'll say hex to primitive. Okay, so if it is 0x 0, then it is GL points. If it is 1, it is GL lines. If it is 2, then it is GL line loop. If it is 3, then it is line strip. If it is 4, then it is triangles. And if it is 5, then it is triangle strip. And if it is 6, then it is triangle pan, or if it is 7, then it is quad. Okay, so this much I think it should be enough for now. So now since we have all this, so in the begin we can place a kind of x to primitive and which equal to, so we'll try again python3 test, and we get this, and this is a triangle fan, that is what we can see. And for the triangle fan, these are the coordinates. So this is what we have seen here. So this comes as a triangle fan. So this comes as a triangle fan. Okay, and 4 are the coordinate of the triangle fan. So this is what we see in the concave. We can specify coloring. Since we have kind of everything done, so I can say color now here. Color is green, red, green, blue. Now if I specify all 3 as color, then in the contour, GL test vertex, first 3 is the vertex, and next and full I means vertex plus color is the vertex data. If that is the vertex data, in the vertex callback we will get all the data, and if length is greater than 3, then we will specify the GL color, and our mode is GL smooth. GL smooth. Let's see what's happening. python3 test.py. Wow. I mean, not bad. It started with 0, 1, 0. We can see. So 0, 1, 0 is this. 0, 1, 0 is this. So from here, okay. So this is white. Then -1. So this is here we have placed as green. So it is showing this green. This is the data we received in vertex. So first 3 is the vertex, next is the color. If we specify, then we can get texel and normal also. And then other are vertexes. So other are, this is white and these all are white, this is green, but this is GL smooth. So, and we have specified GL color here, then other will also get that color. So if we want only one to be green and all are white, I think it is easy. So rather than, so at the end is 1.4. So end is 1.4. So here I want to specify the green and here I will specify the green. So this is the end one. This is how means OpenGL Tessellator is working. So everything would be white except one. Exactly. So all 3 are white. This white, this white, this white, and this came at the end. So this is the green. I mean, anyway, I can play with this. Okay. No one stops us to as a flat model rather than a smooth. So, I mean, there is a difference between flat and a smooth. This is flat. This is smooth. Certainly there is a difference between flat and smooth. So, left side is flat and right side is smooth. So, flat kind of, whatever triangle is being drawn, so it will be flat for those vertices. So, there are kind of triangle fan. So, last one come as a full flat color for that convex triangle. Whereas, smooth, it's not that case. Okay, so then now we'll go with the lab session next. We achieved this. So now we have a polygon with the hole. So there are 2 contours as we saw. So there are 2 contours. So there are exactly 8 vertices. Okay, so I think it's easy now, is what we saw here. So now we'll have hole 1, hole equal to, now we'll specify -1, 1.4, 0, -1, 0, 0, 1, 0, 0, 1, 1.4, 0, -0.5, 1, 0, -0.5, 0.5, 0, 0.5, 0.5, 0 and 0, 0.5, 0.5, 1 and 0. Okay, so what we are doing is, now this is -1, 1.40, -1, 0, 1, 0, 0, 1, 1.40. So top left and this and this and this is anti-clockwise. Okay, -1.4, 0, 1, 0, 1. Now hole 1. So hole 1 is again top left, this, and this. This is again anti-clockwise, -0.510, -0.5, 0.5, 0, 0.5, 0.50 and 0.510. Done. Now we have two contours. Okay. In the tessellation we have two contours. So I think I can just comment it. I don't need now. I'll say for I in range length of hole by 2, GLU test vertex T of and hole I, okay, 3 and hole I. This is the concept what we are doing. Okay, so first we'll do so we'll do GL test begin contour, then contour and GL end contour. So this is for top contour. For the bottom contour, okay, length of hole by 2. So I believe it will be not this case. So from here, length of hole by 2 to length of hole. So first half is the top contour, exterior. Interior, that will become interior, and next half is the next half we are drawing. That's it. So begin contour, first half we are drawing, end contour, begin contour, another contour, second half we are drawing, and we are ending. Okay, end polygon. That's it. Python 3 test.py. Okay, list of India must be integer slices, not the tuple. Okay, so we have done something wrong. Comma, 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 comma. What is the error? Local variable vertex referenced before assignment. Okay, it is moving to combine callback. I think that we don't want, means we don't expect that combined callback would come here. -1, 1.40, -1, -100, 100, and 1.40. I think this is what we want. -510, -5.5, 0.5, 0.5, I think it's okay. Oh, so we got, so this is the field region and this is the hole. Now this is the odd one. So in our diagram, this is actually 1 and this is 2, because both are anti-clockwise, and by default it is 1, so this is getting drawn. Okay, now I would say I want non-zero. If I say non-zero, then both will come into the picture, 1 and 2. Okay, so here now we'll uncomment this. So this is by default, anyway it is odd. I'll say non-zero. Okay, let's try full solid, because both are non-zero. both contours are non-zero. Okay, I can say 2 to the power, I think it works, it doesn't work, I am not sure about it. So that is the idea. So if I say odd, only odd will come into the picture. Okay, so first region is odd region. So in actual sense this is 1 because it is anti-clockwise, this is 2. So odd means only this will come into the picture. Okay, what is happening more on it? There are two primitive it is doing. One is GL triangle strip, one primitive, and another primitive is GL triangle. For GL triangle strip, these are the vertices, and for GL triangle, these are the vertices. I mean, it is like this. So for GL triangle strip, it is 1, 2, 3, 4, 5, 6, 7, 8 and 9. So this way, and for GL triangle, again whatever in red shape, so this is the triangle. So if we mix all this stuff, then it becomes like, okay, it becomes like, if I use instead of odd as positive, both are positive, it is a filled one. Let's see here. No, there are 3. GL triangle strip, GL triangle fan and GL triangle. If we mix all 3 and whatever it is being shown here, with GL triangle strip, these are the vertices. With GL triangle fan, these are the vertices. And GL triangle, these are the vertices. If we really call between GL begin and GL end, this will lead to this diagram. Okay, this is the class of tessellator. Okay, we can do coloring the way we want. So we can specify coloring for some. Like here, I will say, come on, I need yellow for you. Okay, so it does something that we don't want. So whole, it is so we want as yellow. What we are drawing, that we have to see. Combine, callback. Okay, so I in a range of the whole 0, and first is whole 3 and next is, okay, so what is its problem? If we leave it as odd, okay, this is what we wanted. So it should be yellow. If it is not odd and it is positive, okay, positive. Okay, so it is drawing something that we don't like, but this is how it is. So we'll see where is the problem. So we receive GL triangle strip very nicely. In GL triangle fan, we receive as color. Okay, and in GL triangle we don't receive the color. So this -100 coordinate comes under GL triangle fan, and this is how it is drawing. I believe it is out of our hand. This is how it is drawing when it comes in GL triangle fan. So this is coloring. We can specify color for other places also, kind of red. Okay, so other places I believe it took black. If I don't specify this, then it took as black or something like that. Means it drew everything, but this region are black, color is there. Okay, here we can specify as blue, and here we can specify as green. Okay, it is there. Okay, and if we want whole, then we can just say odd, and it is there, whole. Okay, and vertices has, some vertices has color, some vertices do not have any color. And if it is like that, then it goes with the model with kind of that is smooth. Okay. Now it's time for our great star. So for great star, we'll write with color. So I'll say star equal to 0, 1.5, 0. Okay, so this is the vertices, and let's stop with this, and -1, 0, 0, 1, 1, 0, -1, 1, 0, 1, 0, 0. Okay, so there are 5 vertices: 0, 1.5, -1, 0, 0, 1, 0, 1, 1, 0, -1, 0, 1, 0, and 1, 0, 0. Okay, I believe it should be clear. Okay, so our star is like this. If this is the star, then this is the first vertex, that is 0, 1.50, -1, 0, 0. So this is -1, 0, 0. Second one, then 1, 1, 0. This is the third one. Then -1, 1, 0. This is the fourth one. And then 1, 0, 0. So this is the fifth one. Okay, so done. And now I think we can reuse the, so we have done all the stuff. Now it is similar to concave, so I think I can copy paste. Jelly press begin, instead of concave it will be star. Okay, length of the star and only one contour we are specifying. Okay, last time we can see there is no only begin, end and vertex, there is no combine anywhere. There is no combine anywhere. Only, so there is no need for the new vertices. Whatever vertices we are specifying, that is final one, and only the primitives are being decided. Now I can say Python 3 test.py. Nothing we are getting. Instead we are getting some code dump. Okay, repeat is point to add the vertex. So vertex dot extend codes for I in range 3.x. Okay. Type of vertex data, and wait code vertex data. Okay. Let's try our luck again. Nothing. Okay. What is the callback? Okay, combine callback. Type of code, vertex type, one is numpy and dir array, one is list, and one is again numpy and d array. Okay, so coordinate is -0.55, and this is what we are getting. okay, as the vertex data, and then this is what we are getting as weight. So vertex data, we are receiving the colors and it is of size 3. So all colors are okay, but it is only of size 3. Okay. So this is because we did not specify any coloring here. So begin data will for now be, so weight vertex data 0, okay, vertex data 0 and I, vertex data 1 I, vertex data 2 I. Nice. So I can say please do up to 3, means from the 0 only you take, because we don't specify, only color is coming in the combine. So I believe it should be okay. So that is 0, 0, 0 up to 3. We'll try again. Okay, again nothing is coming. Object is not subscriptable, failing to be combine callback. Okay, we are receiving this. So vertex data, everything is fine, and 0, 1, 2, 3, 4. Okay, list.append exactly, take exactly 1 argument and 4 argument. Okay. So list.append so it is combined. Okay, so we'll append with the kind of list. So that it will append its value. I think this is what it is looking for. Or we are doing some error. Okay, probably we need to add this. Okay, so I believe this is the error we are doing. So it should be okay. Okay, so we are getting the star. Okay, and this is the kind of default coloring we are getting. So we'll see it. What's happening behind the scene. So first, all combined callbacks are coming for the new vertices. So this is the new vertex. So yellow color vertices, what we are saying, it is what we are providing, and red color, it is coming from the GLU tessellator, and they are coming in combined callback. And first chord is the new coordinate, and these are the colors that is coming, and each color's weightage is coming. Okay, so this is 5 times we are receiving combined callback, 1 time, 2nd time, 3rd time, 4th time, and 5th time. After that, there is a begin callback for the GL triangle, and everything is GL triangle. And then only vertexes we are seeing, only vertex. So first new vertices properties are coming, and we are returning. So what we are returning is whatever we are receiving as a vertex and color. Okay, so this is what we are returning. Okay, so weight 0 and multiplied by vertex data and 0 and I plus weight 1, vertex data 1I, weight 2, vertex data 2I, weight 3, vertex data 3I. Okay, so we'll try again, and this is what is actual. Okay, now I believe color would be what we are returning as color. Okay, it was exceeding 1 last time. So again, this is coloring we are returning, and again this is the color we are returning. Again, this is the color we are returning. So it is kind of maximum 1 that we are returning. Okay, so I think it is okay, and vertex. Okay, so now we can go ahead and we can place our colors also. Tx.py test, and we can insert our colors now. So whatever we want, we like, kind of 101 cyan color, and then 1110, I believe it is yellow, and 011 and 100, this is red, and 010, this is green. We can try again. Wow. Okay, so this is we are getting a kind of a star. Now we have, I think, positive, we have odd. So since it is odd, so in winding rule we are getting only 1. So only the star, not the whole. If I make it positive, then we can expect full. Positive means both contour 1 anyway it is coming, and 2, what is contour 2 is generated by the tessellation, that is also coming. So it is filled 1. Okay, so what if I, so it is filled 1, full flavor star. Okay, so what about if I say here non-zero, positive, negative, there is no negative, so nothing, no contour coming into the picture. Okay, so we are done. So we saw, like tessellator, there is a library OpenGL that doesn't handle, but GLU handles it. And these are concave polygon where any edge comes outside of the polygon. So we come into the GLU tessellator come into the picture, and if we feed the concave, okay, so if we feed the concave, then convex polygons comes into the picture. The methodology is like this, where kind of we register the callbacks, and once user calls the GLU tessellator, it reads the polygon and it calls the callback. Combine is called if new vertices has to be generated. Okay, when we specify the vertex, then it has to be in one direction. If direction is anti-clockwise, then the region under it is positive, and if it is clockwise, it is negative. So it is clockwise, it is negative, keep on adding, and here top is clockwise, so negative, anti-clockwise, positive, -1 + 1 0, again 1. So if we have contours, then we can specify which contour we want, which contour we don't want. Okay, so I think we can show everything in one go. So anyway, star we have showed. Okay, so I can kind of just execute it and keep it off. So I believe we have to okay, so we want odd. Okay, so this is our star, and concave we want, so we will, okay, so only concave will come, so other we have commented. So this is Mr. Concave, and now we'll do with the hole. So we'll come into type and here. So okay, begin contour, end contour, begin contour, end contour. So only the whole stuff will come. Syntax error 65. Okay, so we have on the screen, we have what, 3 we kind of showed. So this is this is concave, this is not a convex with a hole, this is not a convex, and intersecting edges.